Hey, it's Tony here, and I'm going to show you a new capability in the Kepler open source planet image processing software, where you're able to do now a one-stop going from sharpening of your images all the way through to derotation, all in one solution. So with no further ado, let's get started. I've got my Kepler program open, and the first thing I'm going to do is I'm going to open up one of my images. And so I'll open up this first image here, and you can see that if I use my mouse wheel, I can zoom into that image. I'll resize this window down here a little bit, and I'll right click to drag this. If I click around the red spot, you can see there's a magnified image kind of opens up here in the screen below. And so we'll use that as we do our processing. The first thing I like to do, and we'll need this for the derotation steps, is I'm going to rotate the image so that the Jupiter's North Pole is facing at the top. And so go ahead and do that. And let's just change the rotation a little bit. So it's roughly North Pole at the top. That's close enough. And I'm going to select this button here to deselect, because we don't want to look at the original image. I'm not interested in that. Go ahead and fit this, and then mouse wheel, and we'll zoom in just a little bit. The next thing we want to do is, just as I explained in other videos, the Kepler software kind of follows a chronological order of the steps, and that's reflected by these tabs up here. The first thing we want to do is do some sharpening. And so I'm going to select the wavelet tab. I'm going to click on the auto size filter, which is the sharpen filter auto adjustment. And then I'm going to move these sliders over to about 100 for the first one. You see straight away the image starts to sharpen. I might even move that over just a little bit more, maybe to around 125. And then for the next layer, I'll kind of move that over to about half of that. So around 62, 63. And then the layer 3 around half that again. So around 30, 31. And you can see we've got an image that's getting nicely sharpened with a little bit of noise taking place as well. The next step that we want to do is go ahead and the FFT tab. And so we will apply some denoising. And I'm going to click on the enable denoise, and I'm going to click on auto denoise button here. And you can see straight away that the noise is kind of reduced a little bit. I'm not going to get too aggressive on this, so there is a bit of noise still remaining. But if you remember, we are going to do a derotation later in the processing. The next thing is setting the RGB. And so you can see here on the curves, the red, green, blue channels are kind of separated a little bit. If I click on RGB balance, that's going to kind of bring those together and kind of adjust the color a little bit. And we'll leave that like that. The other thing on the next step is the Tools tab. So now we can do some sharpening. We can sharpen some of the luminous detail, and I'm going to enable that. And you'll see that there's some subtle sharpening taking place as soon as I increase the strength here. And I'm going to increase that. Actually, let's go crazy here so you can see the more dramatic effect. And I don't want to go too much on the sharpening. So let's dial that back to about 2. And if I select use contrast, that will kind of weight the sharpening towards the more high contrast edges. So let's take that to about 1. And then the next thing we want to do is there is a local contrast enhancement that you can play around with. But for the purposes of this video, I'm not going to go ahead and use that. But I encourage you to play around with that for yourself. The next one is the de-rind settings. Now, if I look at the limb of Jupiter, I don't see much of a rind effect. So I don't believe for this particular video that we need to use the de-rind steps. And I'm not showing any moons in this particular image. So the orbital tab, which is a way of emphasizing the brightness of the moons of a planet and then editing the moons so they have more circular shape, we don't need that either. But I encourage you to take a look at other videos on the YouTube channel where we go through that process. And the next thing you want to do is this batch button here, or the batch tab. I've just worked on one image. And so what I'm going to do is I'm actually going to apply these settings to all those images in that folder. So if I click on Add here to input the files, and I'm going to select all of them, click on Open. And you can see here this little inlay here. It shows you kind of the rotation, and we're roughly got the North Pole at the top, which is what we want for the derotation step. And we will then go ahead, and if we click on Refresh Summary down here, it tells us all the processing steps that are going to be applied as a batch to all of the images. And so if I run the batch, click on Run Batch. Actually, first I need to select the folder that they're going to go into. So let's go ahead and do that. So we will actually just keep it in the same folder. And so we've got the folder up here, and we will select folder. So there's selected. And then I'm going to go ahead, and I think we'll save these as TIFF files, 16-bit. And we will give this folder a name. We want to save this batch. So let's call it, well, let's just call it batch. And then we're going to click on Run Batch. And you can see it's going through all of the images. And it is now completed. If I now go over to that folder, you'll see here's a batch folder. And look at that. All those images have been processed with the same settings as the first one. And they're all rotated as well. So the north is facing up. Let's cancel that. So as I said at the beginning, you'll notice if I zoom into this using the mouse wheel, there's a bit of noise still showing there. And we're going to reduce some of that using a feature called de-rotate. What de-rotate does is it uses IAU geometry and JPL horizons data, and it basically maps the Jupiter surface. And so that if you've got, say, a video capture of Jupiter, and then you've got a resulting image file, and then you've got another image file from another video capture, let's say 5 minutes later, and then another image file 5 minutes after that, what de-rotation does is it kind of meshes those images together and does the calculation and allows for the rotation of the planet. That's the explanation at a very high level. And so we've got our batch folder, and here's a timestamp here on those images. And so we don't want to go too crazy in terms of too much of a time separation for this de-rotation. So what I'm going to do is I'm going to choose the first 3 images, and you see the time difference is about 10 minutes. So let's go ahead and open that, and then let's go ahead and run the de-rotation. You notice I've got my location, elevation. I've selected Jupiter as the planet. And now let's go ahead and open up that folder. And here's the batch folder. And here's the de-rotated image. Just double click on that. And if I zoom in, you can see that the noise is quite reduced from that de-rotation. Unfortunately, the seeing conditions were not that great. And so we don't really have the crispness that you might see in some Jupiter images. But I think you would argue that the de-rotation has certainly had an impact. So that's it. That's the full end-to-end workflow using Kepler, including the de-rotation capability. I encourage you to play around with it and see what you can come up with. Thank you for your time.